computer. Next. Okay. So yeah, interesting that right now Avon, Indiana is the coldest point in most of the world right now. And do either of you know where Point Barrow is located? If you know, you can type it in the chat. Point Barrow, sometimes called Barrow Point. And if you don't know, it's okay. And you're not allowed to Google it. I'll give you about 20 seconds to type something in. You can just type the state or whatever. Anybody? 7 seconds. Aha, I don't know. Okay, way to be honest. That's totally okay. That's okay. Point Barrow, also called Barrow Point, is the most northern point of the United States. It's like it's the most northern town in Alaska, and it is in the Arctic Circle, and they are only 3 degrees below zero. And in doing some research, I've also learned that there is no place right now in the Arctic or the Antarctica, South Pole, that is colder than -11. And we're also comparing, you know, apples to apples, because the time zone isn't an issue, because there are no time zones in the Arctic, right? There are no time zones because if you think about the longitudinal lines that descend from the top of the Earth to the bottom of the Earth that divide our time zones, those bands get very narrow at the North Pole and South Pole, because those bands, dare I say the word, converge on each other, and you just don't have like Eastern time and Western and Pacific up on the North and South Pole. So interestingly enough, Avon is colder than either the North Pole or South Pole. However, it is not the coldest point in the world right now, because there are several places in the United States that are a little colder, like through Michigan and Wisconsin and the Dakotas. But anyhow, hey, I thought that was interesting because it had the word converge in it, right? We can use the word converge with weather. So anyhow, I am going to go ahead and take a look at some of our quizzes. We're going to take a peek at quiz 1 that came from section 8.1. Don't worry so much about the quiz numbering system here, because this numbering system was in effect the previous years when we did the vector unit in the 2nd semester. I understand that some of you might have quizzes that are of a different form. Some of the numbers might be different, but for the most part, you're going to see a very similar kind of question. And hopefully, as I go through each quiz, I'll at least, you know, you'll get lucky enough to have like your form show up at some point. So at least we hope that's the case.
Is that Tony?
So what's that? You guys making fun of me already? We haven't even started. All right, so for number 1, we are going to match this sequence, A sub n, with one of the 4 graphs that was given below. And you've got to kind of go back in time here a little bit. This is back in the old, you know, sequence days before we started to add things together. So in this particular case, your best bet was just to probably list out some terms. Let A1 take over, let N be 1. And of course, we would have 3 over 1, or 1 factorial, which is 1. And if we let A2 take over, we would have 3 squared over 2 factorial. And if we find A3, we would have, and that would be 27 over 6. Now, some of these we might want to think about converting to some decimals so that we can make better sense of them. 27/6 doesn't convert so nicely to a decimal. Well, actually, I take that back. It does. It converts wonderfully to a decimal. 6 goes into 24, I believe, 4 times with 3 left over. So that would make 4.5, right? Does that sound right? Did I do that right? That sounds right, doesn't it? It appears there's only one of these that could possibly even make sense at this stage, and that would be C. If you weren't quite sure, you could take another point and go from there. But pretty easy problem, especially when you consider where we've gone since this particular case. If we look at number 2 here, determine the convergence or divergence of the sequence with this term. As we move closer to your test next Tuesday, you're going to have to remember that there are maybe two problems that will focus on the 8.1 idea of convergence. That was completely different from everything else in the chapter because 8.1 wasn't about adding things together. It was just about the terms themselves. And we only have one means by which to figure out convergence or divergence with a sequence. So you guys just look for the word sequence. Or if you don't see a summation symbol, there's a pretty good chance that you're dealing with sequence, right? And that one way was just to take the limit as n approaches infinity. Now, don't get too terribly confused because I understand that this is also a sort of version of the nth term test for divergence, but we're asking two different questions here. I just want to know, are these terms diverging or converging? So we would take this limit. Of course, we're going to get an infinity over infinity. So L'Hopital's rule will probably come in handy. And when we take L'Hopital's rule, this 8 could come out in front. We know that, right? By logarithm rules. And then the derivative of natural log of n is 1 over n. And the derivative of 3n is 3. And now when n gets to be really, really big, it's going to tend to make this top become 0. And you would end up getting an answer of 0. And that means that the sequence itself does converge to 0. I hope this doesn't confuse you, but what if there was a summation in front of this and it was a question from the second part of the unit, from 8.2 to 8.6? Well, if we would have used this approach, which is now officially called the nth term test for divergence, we end up getting this value of 0 that we don't want, which just simply means that the nth term test is inconclusive and we would have to move on to some other test. And if you're thinking what test it might be, this probably is an integral test maybe. I could see how u could be the natural log of n, the derivative is 1 over n, things could possibly work out, but we're not going to do that. I think we're going to see a problem maybe later on where we use that integral test. Problem 3. This was a great problem. I think you guys did well on, but this problem came back and it haunted you when we took the section 8.2 quiz, problem 1. We'll get to that here in just a moment. But listing out the first 5 terms is really nothing more than doing what you did in problem 1. It's just that you're not graphing it. So if we let n be 1, okay, -1 to the 5th, okay, that just means we are going to have a negative sign for our first term, and probably every odd term we can reason out that there's going to be a negative sign. And then 17 over n, that would just be 17 over 1. Okay, that's pretty easy, right? I guess you can get rid of possibility B. Then if we let n be 2, we have 17 halves. And then knowing that that's a positive, we are able to really deduce right away that the answer is A. You don't have to go any farther than the second term. And that's perfectly okay. And as long as you guys can get a correct multiple choice answer in the quickest time, that's a good thing. That is a good thing. Moving on to the free response question. You were all, I believe, given the same one. So if you had a slightly different form, you all should be sort of back together now. So it says, consider the sequence with this nth term. Determine if this sequence is monotonic. Monotonic means strictly non-increasing, strictly non-decreasing. It's been a while, I know, since we've done this, maybe a couple of weeks now. And it says that we had to justify by demonstrating a method besides listing the terms. So if you remember, what that dealt with was initially you listing out a couple of terms. So A1, we know would be 1 over 2 to the 3rd, which is 1/8. The second term would be 2 over 2 to the 4th, or 16, which is also 1/8. So that's not real good. I mean, I can't really tell if we're non-increasing or non-decreasing. We're just staying the same. So I need to get another term here. If I go with 3, I get 3 over 2 to the 5th, which is 32. Okay? So at this stage, I am pretty certain that going from 4 32s, which is what 1/8 is, to 3 32s, I'm probably more apt to be decreasing than anything else. So that means my conjecture is that any subsequent term is going to be less or equal to than any previous term. So I'm questioning this. So I'm going to go ahead and rip out my n's, change them to n plus 1s. This might feel a little similar to like what you do with the ratio test, which is totally awesome. It's great to think that way. That's why I like introducing this procedure to students. Then we will cross multiply 2 to the n plus 2 power times n plus 1 would be possibly, we hope, less than or equal to 2 to the n plus 3 power times n. I'm going to continue this over here. The 2 to the n plus 2 and the 2 to the n plus 3, we understand that we can rewrite each as something along those lines, right? 2 to the n times 2 squared. This guy could be 2 to the n times 2 cubed. And what that will allow happen is the 2 to the n's will basically cancel away on both sides. So you would only be left with, for a moment, 4 times the n plus 1 and 8 times the n. But if I take, well, let me go ahead and write that. I don't want to get too far ahead of myself. 4n plus 1 less than or equal to. I'm still not sure if this is a true statement or not. If I divide both sides by 2, I could say 2 quantity n plus 1 less than or equal to n. And then if I distribute the 2 through, I'm going to be in a position where after I subtract n over, I would get n on this side. And if I subtract 2 over, okay, what did I mess up on, guys? You can either put it in the chat or you can, if you want to unmute yourself, but I did something terribly, terribly wrong with this problem because n is not going to be less than or equal to -2. So are my terms right? N plus 1 to n plus 3. Okay, that looks good. That looks good. I cross multiplied correctly, right? That looks good. I broke apart correctly. That looks good. Oh, this should be an 8, right? I see what I did. I was kind of in a hurry. I was thinking I was going to be doing that reducing. I'd never reduced yet. I had 2 squared on the left side and 2 cubed on the right side. That will make a big difference, guys. Sorry. So that would be an 8n. This would have been an 8n, and I'm still messed up, aren't I? No, I'm not. This would be -6n, -2. If I divide both sides by -6, I guess I would have to flip my inequality sign. And we know that that's true. That's true. Now, it's likely you guys might be staring at your quiz if you have it in front of you and be like, whoa, wait a minute, I don't have anything that looks like this, but he didn't take off any points. There's a lot of different ways that you could simplify this. I was just looking for just 1 or 2 poignant steps from this statement that allowed it to be pretty clear that you had something true. I don't think this is really clear. I don't think just stating that is very demonstrative. Okay, but any step pretty much subsequent from this point on, I think was very clear. Hopefully that makes sense to you guys. So. And then as far as the boundedness is concerned, I didn't really expect to see a lot of work for part B. I just gave a point really for each part of the boundedness. But we established the fact that this sequence, it does indeed start at 1/8. It is going to be non-increasing, so it's never going to get larger than 1/8. So you could say that it's bounded above by 1/8. And you don't have to call that N or M or whatever. Some of you did, and that's fine. And then it's bounded below by, well, if we just keep going farther and farther with these terms, we're just getting smaller and smaller, never to the point where we're negative. So 0 would be our bounded below value. And it's weird because, guys, we never reach the 0, but it's still considered a bound. 1/8 is reached, it's touched, it's attained very early in this sequence, but we can still call that a bounded value. Sometimes kids think a bounded value has to be something that you arrive at. Well, that's not true because of the concept of limit. We can just get close to it. So hopefully this helps. And I think we may have gone through this quiz a little bit, and I understand that with period 3 or period 2. I know I may have had some people, I haven't looked at the yet, but there could be some people in period 5 that have tuned in. I wanted to make sure that they had a chance to see it. All right, so we are going to move really quickly to quiz 2. That would be section 8.2. And there were a few of you that, as I was passing this quiz out the other day, I kind of walked around the room and pointed out what went wrong with problem 1. And there's a big difference between problem 3 on the first quiz that I did and problem 1 on this quiz, even though they're all about writing out terms. I want partial sums this time. So it's not good enough anymore just to list A1, A2, A3. Now, it'll be helpful to list those. For instance, A1 would be -4 over -5 to the 0, so that would just be -4. Hey, what do you know? All the series start with 4, -4. Then if we go to 2, we end up with -4 over -5 to the first, which is +4/5. Well, immediately a lot of you gravitated towards this guy. That's not the partial sum. The partial sum would require that we add these two things together. So if I give -4 a common denominator of 5, and then add it to -4/5, that second piece should be -24/5. And okay, I'm wrong. I'm so wrong on that because that's not what I got. Why am I having such a bad morning, guys? Double check this. If I let n be 2, -4 over -5 to the first, so that's, +4/5. I'm an idiot, right? 2 negatives, what do 2 negatives do? They make a positive, my bad. So that should be plus. So -20 plus 4 would be -4. That should be a -16. And I think we only have one option that's got that sort of characteristic. I wrote the problem like that so that you could find the concept, get it answered, and move on. So just be on lookout for that exam. Okay, this is a concept that, trust me, you're not the only people across the country that would be bothered by that. There are a lot of kids that would answer A for this problem. Moving on to this rest of this quiz, a lot of these problems were very quick hitting concepts, like 2, finding the sum of this convergent series. We have to know that if I ever ask you that question, you know that this has got to be a geometric series or potentially a telescoping. Certainly not telescoping. Anybody coming in, I'm going to try to mute you guys because I'm getting a lot of feedback. I don't understand. I've got it set so that you would be muted immediately upon entering, but that feature hasn't been working for a while for some reason, so I'll just kind of pay attention to that. So on this particular problem, we will use the idea that the infinite sum, is the first term divided by 1 minus the ratio, and we're lucky that we can use this because we do start at 0. If we didn't start at 0, we'd have to make some adjustments. So our first term, well, that happens when the n is 0. -5/6 to the 0, of course, is 1. So our first term would be 10. That first term is always the coefficient when n is 0 anyway. And then 1 minus the ratio, 5/6. This is 10 over 1/6, and that would be 60. And man, it would be nice if I could do some math here. Let's do this correctly. The ratio is -5/6. This whole thing is the ratio. So this would make not 5 or 1/6, but this would be 11/6. Is that right? 1 plus 5/6 is 11/6. And then if we multiply by the reciprocal, 10 times 6/11, we get 60 over 11. And it turns out that that is an answer choice. All right. Taking a look at 3, while problem 3, telescoping series, will not be featured on your BC exam, you will see it on your unit exam, and that will be the last time that we hear of it, talk of it, speak of it, and forever, you know, unless obviously you guys go on to take more mathematics and it might come your way. But for this particular series, we do have to at least investigate on the possibility that we can rewrite it and it be of the telescoping form. So I am going to do just that. I'm going to take this wonderful looking already factored denominator series or expression and know that there's most likely a way to bust this apart into 2 fractions where each contains the denominator components of the LCD and some constant for the numerator. So we multiply through by the least common denominator. We end up here. Pretty straight up. And then we use the wonderful Heaviside method, and we find out that 6 would be equivalent to negative 2b, which means that b would be negative 3. And if we use the fact that n could be negative 6, 6 would now be equal to positive 2a, which means a is positive 3. Now, this is pretty powerful because once we rewrite this series from n going from 1 to infinity, the a is the positive 3, and the b, being negative, places the minus between, and that gives reinforcement that this is very, very, very likely telescoping. You've got to have this minus sign. Without any hesitation, I will say the best way to answer what is the sum of a telescoping series is to list the terms. How many terms? It all depends on you. But we're not going to have to, and I keep picking on Emily. Emily's here in the room. We're not going to have to use 20 terms, thank goodness. Like I almost forced you guys on that stupid homework question that I put because you didn't have any patterns. But I wouldn't list just 1 term. So let's go ahead and throw 1 in here, and we're going to get 3 over 7 minus 3 over 9. You know what? It's way too early in the morning to kind of reduce fractions, so we're just not going to do that, right? And then we let n be 2, so I get 3 over 8 minus 3 over 10. Rolling right along, let n be 3, 3 over 9 minus 3 over 11, plus 1 more. 4 seems to be my magic number, isn't it? I like 4 terms because 4 terms, I've discovered, keeps us out of trouble. Now, anything canceling? Yes, we see immediately that the negative 3/9 perhaps cancel, the negative 3/10, positive 3/10 cancel. Safe to say that this guy here would cancel with an impending term there. And I'm going to be good. I think the only things that really are going to stick around are these 2 puppies. And then sure, there's going to be some kind of a nasty 3 over n plus 8 type of term that's going to stick around, but we don't really care so much about him because as n gets really big, this will zero out anyway. So your answer to this problem is just the sum of these 2 fractions that I have highlighted, 3/7 plus 3/8. Ugh, that's going to be kind of fun, isn't it? We got to get a common denominator of 56. So that 3 would be a 24, that 3 would be a 21, and that's 45 over 56. Okay. There's your one little telescoping problem. You guys destroyed number 4. You guys did a really good job with this. Although there is a little piece about part B I want to talk about that I thought is interesting. So first of all, not a single kid, all 59 of you got part A right. You looked at this and you immediately knew it was geometric. That's a good thing because, boy, if we thought that this was telescoping, I don't know where we would have gone with it. But this whole thing right here is going to act as our R, right? And it's nice that we have the general behavior is starting at 0. So our job is to figure out what the interval would be so that this series would converge. And while this problem may not seem a big deal to you, it's actually a huge deal, because this is the first time that you ever saw what's called a power series, which, if you're somewhat curious, that's the title of section 8.8 when we get to the new unit. A power series is just a summation, a series, but there's now an x somewhere inside of that expression, and we have not seen that outside of this particular example. And when we have that x, we can do much more interesting things with these guys. And because we don't know this x, we don't really know its convergence or divergence behavior. And if we want this thing to converge, we darn well better be using the right x's. And that's really what this question was all about. So we remember from geometric series that the r value has to have an absolute value that's less than 1 in order to converge, correct? Now, it's not necessary that a student do that, even though that's written in the notes, because we know that this absolute value is probably going to be a positive anyway. So I didn't worry so much about this. But what I wanted to make sure that we did is somehow recall that you're going to have to set this up as an compound inequality. Whether you do it early or if you multiply the positive 6 over first and then set it apart like this, either way is fine. You're going to get the same answer. But when you multiply everything by 6 and then add 5, not subtract 5, but add 5, this is what you ought to be looking at. And I accepted this as an answer, as long as you had the interval not including -1 and not including 11. Because if you did include 11, let's say, then your ratio would be 1, and you will not converge, because you're just basically taking 6 and adding 6 over and over and over again. Okay, now here's the interesting question. A lot of you did this. I guess I could write it like this, huh? You may have written it in, maybe you wrote it also in interval notation. Basically, you excluded 5. You excluded 5. And I was okay with that, because you were given some information in the notes that indicated that r cannot be 0. Because if r was 0, then let's face it, we don't have something very interesting here, right? We're basically summing 0. Hey, let's do that all day long. That'll be fun. 0 plus 0 plus 0. But if you think about it, wouldn't that converge by like the definition of convergence? So I'm okay. If this was left as is, I would be fine with it. If you wrote it so that you excluded the 5, I'm fine with it. I don't want you to worry about what the AP exam is going to want, because they tend to kind of steer away from things like this. And if they don't, I'm sure that they would exercise the same flexibility, or they might even say, outside of r equaling 5, what are the other values for which this series would converge? They might ask something along those lines. So hopefully that makes a little bit of sense. Okay. I'm kind of looking here. We for the section 3 quiz, I've got one person who still has to take this thing, but that person is not in the room. So I'm going to go ahead and talk a little bit about it. I wanted to post this. I kind of promised everybody that I would record this. It's being recorded. I'm going to see if I can try to post it up on Schoology at least. And then remember to take this down next year so that people don't have access to the quizzes before we take the quizzes. And I can always give a different version of this quiz, because I think I've got one in my files somewhere. So let's talk about, if not all of these problems, we're going to talk just about a few of them. And then I wanted to just pick a few of the problems at the end of the 8.6 notes. I don't know, see if you guys have any lingering questions. If you do, great. And if not, I want to get you on your way, because I know you got some other classes that you want to take a look at. You might want some Netflix movies to watch. I don't know, you might want to go play out in the dangerously wind chills. I don't know, maybe. So for this particular quiz, this was 8.3, covered a lot of different things: P-series, integral tests, nth term test for divergence. So number one, it says determine the convergence of this particular series. Yeah, I made it tough on you here, didn't I? Didn't write out the closed form, kind of forcing you to do that. So you have to come up with this form all on your own. So what is that? You've got basically a term at the beginning that could be thought of as 1 over the square root of 1, right? 1 over the square root of 1. So what do we have? 1 over something, maybe 1 over the square root of n, as long as n starts with 1 and ends with infinity. Does that look reasonable? What kind of series is this? Indeed, a p-series. And the p-value is equal to 1/2, right? Not negative half. Don't think of it as negative half, because the p is the exponent of the piece that's already in the denominator, Because that's less than 1, we know that this is going to diverge, right? And really, there's nothing more to it than that. Okay. If I recall correctly, this was a quiz that, help me out. Was this in the chat? Somebody tell me, was this the take-home quiz? Was this the take-home quiz? I can't remember if 8.2 was the take-home or 8.3. 8.2 was the take-home. Thanks, Emily. Okay, yeah, this is the one that we took in class. You're right. Okay, for number 2, it said to use the integral test to determine convergence and divergence. It says that you don't have to show any work in determining whether the integral test applies. Thank goodness, because that's going to take forever and it's going to eat up a lot of space and nobody's going to be happy. So what we'll do with this is we're just going to flat out begin to integrate this thing. I have no problem if you left the variable as an n. It's totally okay. I'm in my mind thinking that we've already sort of equated this series expression with n to a function expression of x. We know we're going to go from 1. We'd like to go up to infinity. Oh boy, that would be nice, but certain things called the fundamental theorem of calculus won't allow that. So we kind of write it like that. Okay. I was not very picky about notation for these problems. If you had an integral that had at least one step of work, you were given full credit if your answer was correct. So in this particular problem, the u would be 7x plus 2, the derivative of which is 7. So we would offset with 1/7. And then we're just integrating 1 over u, which is the natural log of the absolute value of the u. And I know there's still a 4 that has to be utilized, so I'm just going to put that 4 up in the numerator. All right, so I think I've integrated this correctly. All I need is my limit in front and some boundaries in the back. So we go ahead and throw those boundaries in, and we see that we've got the natural log of absolute value of 7b plus 2. I think that's pretty much all she wrote right there. I think we are staring divergence directly in the face, aren't we? Because if b becomes infinity, this is going to grow really large, and it doesn't really matter what he does at that point. So this thing is going to diverge. Now, knowing what you know now, you guys, you probably would never ever even think to use the integral test for this, because couldn't you apply like a super quick comparison test? And I'm talking about a comparison test that requires no pencil or paper manipulation. In other words, this could be one of those quick hitting Roman numeral 1, 2, 3 multiple choice kind of series questions where you look at this and you just say, wow, that looks an awfully lot like the summation of 1 over n, which diverges. I doubt this 4, this 7, and this 2 change much of that. And thus you can conclude that that diverges. On 3, oh gosh, another integral test. Again, the questions on the other form, I think, are in a different order and perhaps have a slightly different look to them, but I think you're going to be able to follow along. In fact, those of you who might be following along on the other version of the quiz might be doing themselves a favor, because you actually have to think a little bit. And if I'm not mistaken, all of you that are in this room look like you're all period 2 people. You guys have the 8.3 quiz in your possession that I gave, but I don't think I gave the other class because of the person that still needs to take it. So if I'm wrong about that, let me know, but I'm thinking that you have the ability to look off of yours if you have your folder, binder, whatever with you today. So for this one, use the integral test to determine convergence, divergence. We're not going to apply any special conditions. So yep, we just hop to it. We have the limit now as b approaches infinity of the summation of 2 up to infinity, up to b of ln of either n or x over either n to the 8th or x to the 8th. All right, here u is going to equal something. Oh, u's not going to equal jack squat in this problem, is it? I was kind of like getting sort of cocky here, thinking u could be ln of x and the derivative is 1 over x, but it's not an x, right? So first person in the chat, who can tell me what do we have to do to take this integral? You can even abbreviate. Who can do it? Who can do it? It's a race. It's a race. 25 bonus points. No, I'm just kidding. I'm just kidding. Does anybody know? Split up the fraction. Okay, Katie, you are correct. That's definitely something that's going to be the first step, and then we would end up using what technique? Are you guys stumped? Do you remember? Does that help? It's integration by parts, isn't it? Yes, good, Daniel, good. It is integration by parts. So it follows with what Katie was saying, splitting up the fraction. So we would basically think of this as maybe ln of x times 1 over x to the 8th, perhaps. And we could let the u be ln of x. You want to avoid it being the dv. And we could let the dv be x to the negative 8th. And now we should be okay, because du would be 1 over x dx. And v would be, oh gosh, what is this? Add 1 to the exponent, divide by that. So something along those lines, right? Guess we need a dx right here with this. So, wow, I need to think more clearly in the future about giving you a little bit more room here. So u times v would be negative 1 over 7x to the 7th. I think I did that right. U times the v. I still need my ln of x though, of course. So that would be uv minus the integral of v du. Okay, so if I put these two guys together, basically I have negative 1 over 7x to the 8th, if I'm not mistaken. I'm going to bring out that negative 1/7 to make this look a little easier on the eyes. So it's now a positive 1/7. And now I'm just integrating 1 over x to the 8th. I have lost all of my boundaries because I'm not concerned about those right now. I'm more concerned about getting this integral taken correctly. But you know what? I kind of wonder sometimes if that even makes a difference. And I would have allowed students to bail out on this problem at this point because, and you tell me if I'm right here. There's this limit still in front, right? Well, no, let me take that back. Let's keep going. Let's keep going because this is a little tricky here still. All right, so let's integrate this 1 over x to the 8th again. And I'm going to have to borrow some space here for problem 4. Put the ln of x up on top. How's that? Golly, have we done this already? Yes, we have. Isn't it this thing? So I would have basically 1 over, let me think. It's actually this thing. I take that back. It's that thing. So I would have 1 over 49, and I would have a negative because this is a positive times a negative, and then an x to the 7th in the bottom. This will go from b to 1 to 2, and I still have this limit. Now, this is the part here that's the trickiest because we could conceivably maybe diverge there. So let's plug in our b. There's our b plugged in. And then let's plug in our 2. And you know what? This 2 is like, I don't think it means much of anything here. Because we are definitely going to have a constant sort of convergent type of thing over here. I just don't want to figure out what it is. 2 to the 7th, I don't want to do that. I don't want to mess with that. See, this is all good. This is all okay as far as convergence is concerned. This is what concerns me. This is going to be 0. I'm not concerned about that. So it's really what this does. And I think we have one more L'Hopital's rule going on in this problem or in this quiz. So we would have 1 over b over negative 49 b to the 6th. Well, if that 1 over b sort of intercedes down here, you really have negative 49 b to the 7th, I believe, right? With a 1 on top. So if b gets really, really big, this thing's going to end up being 0, right? Now, do you all remember what the conclusions are for the integral test? I'd be amazed. I'd love, again, for somebody, if you want to type it in the chat, you would so impress me. And I don't even know if I can find my chat anymore. I got like 15,000 things on my screen. I know you only see the one thing, the slide, but what do you think? What has to happen? Your answer has to be both. Oh, somebody said it. Who is that? Whoever said that is absolutely awesome. Finite and positive. I'm going to give that person an A+. Yep, you have to be finite and positive. 0 is finite, but not very positive. So this guy here ends up diverging. This is a divergent series, I believe. So is that what your quizzes said? Correct me if I'm wrong. I don't have the key in front of me. I brought everything home, notes, binders, homework binders, but I did not bring the quizzes and their keys back. Okay, luckily, this is the worst part of the quiz. Most everything from this point on flowed a little bit better. For instance, in this particular problem 5, P series, we have an exponent 7/5 that's bigger than 1, which is a good thing if you want to converge. So this thing would converge. And like I said, it wasn't my intent to work through everything on this because it's going to take away from some of the other things that I wanted to do before you guys go. And if there's any questions among the group later, we can go back to this part of the quiz and see if there's any of these other problems that we wanted to look at. Because I know that 9 and 10 you might be a little concerned about, but honestly, if you look at the one problem that we did at the end of the 8.3 notes, it's dovetailed right up to number 9 and 10. They're basically the same question. So let me do this. I am going to open the notes for 8.6, so I'm going to share something different with you guys. Boom. You should now see the 8.6 notes. Most of these we already ran through, yada, 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 yada. And each class, period 2 and period 5, ended at different spots. Trying to remember. For some reason, I think that you guys, with you guys, we did get to number C, or letter C, I hope, right? Does that sound reasonable? That was one that required the integral test. You have to bear with me, guys. I'm getting old. I can't remember what we do in one class versus the other from one day to the next. So I would just like to run through D, E, F, G as quickly as I can, just to get you guys a little bit of an insight into the whole big picture on how we could handle some convergence tests. So if we happen to see D shows up on a test, day of the test. It's like, oh my gosh, panic, panic, panic. What do we do with this? Well, maybe your mind is thinking, nth term test for divergence. Let's let n grow really, really big and see what happens. Well, you're going to get 0, so not a great test. So it's very likely that you might think, maybe we could compare this. What would this compare to? Well, it compares to 1 over n quite nicely, doesn't it? And we know that that is our divergent harmonic series. So you could either use the airplane test, or if the airplane test is just a little bit crazy for you, you could use the limit comparison test, something that we haven't talked about here in a few days. And remember, the limit comparison test says you would take this limit and you could compare. We like to put the original function on top and the brand new comparable function on the bottom, and then we simplify the heck out of it, basically multiply by reciprocal, and then we come to the realization that that limit is 1/3. That is a 1 over 3 limit, no doubt about it. What does that mean? What do we have to have here? We have to have a result that is finite. That is numerical, right? And that value could be 1/3, it could be 3, it could be whatever we wanted it to be. And because of that, we're going to say that this is convergent. Or I'm sorry, divergent, because we want to match this up here. Hey. I think I'm getting myself confused. Comparison tests, that is finite and positive. We want comparison tests to be finite and positive. Integral test, that's something different, isn't it? You guys didn't correct me in the chat. I'm going to call something up here. I'm going to share with you so that we don't have any confusion, because that would so make you coming to this boring e-learning session not worthwhile. So I'm opening something here and then I'll share this and then I'll get this clarified. Apologize for this. I am now sharing the notes for section 3. So hopefully you see the notes for section 3. I'm going to fast forward to integral test here, and the integral test doesn't say get a finite and positive answer, right? Indirectly though, it does say get a finite answer. So if I were to go back to the quiz, so I'm going to share the quiz again. And I want to look at that last integral test problem, number 3 that we just did. Geez, this is a mess, right? We got a limit of 0, did we not? We got a limit of 0. That means that this improper integral has an answer. It converged. So the answer to problem 3 should be converged. Can I please get a yes in the chat if that was the correct answer? I did not mean to say that that thing diverged, because you guys might have been looking at your quiz thinking, this is not right. I mean, 3 should definitely converge. I mean, if you think about it, that end of the 8's pretty big. That ln of n's not going to change a whole heck of a lot. Thanks, Katie. I am so sorry about confusing you guys. All right. For the integral test, all you need is a numerical answer, and it can be negative or 0, and that will give you convergence. If that answer is infinity, then you get divergence. Okay, I will try to get better, guys. I'm sorry. So if I go back to the notes, we now definitely see that D is going to be divergent because we did not get a finite, because we got a finite positive result, and that means we match what we had up there. Okay, part D. Is it pretty darn clear what test you guys would use for, I'm sorry, part E. For part E, what test you would use? I mean, I would hope that everyone would just be like all over the alternating series test. It's the only test I want you to even think about using when you have an alternating series. So the very first thing that you want to do with this is go ahead and consider what's going on with the absolute value. Right? You're not even really doing the alternating series test yet. You are just taking the absolute value of this basically to make your life easy. Because if you deem that this result converges, you're done with the problem. You have nothing more that you have to do with this question. You're completely finished because you know that that means absolute convergence. It turns out that this diverges, and it basically diverges for the same reason that the previous problem does. I am not going to make a student show me that this diverges by a comparison test. In fact, the test that you took, the quiz that you took recently, the free response question on the back had a little piece to it like this. I think that was the 8.4 quiz. And if you just stated that this diverged without telling me why, that was acceptable. That was totally okay. So then we can move into the alternating series test. Criteria 1 says take the limit of the non-alternating component, which is 3 over 4n plus 1. And of course, when we do that, we get 0. So that checks out because we want 0. And then test 2 says you want to see if this is a situation where the nth plus 1 term is less than or equal to the nth term. Kind of a fancy way of saying that this thing sort of kind of decreases, but it really non-increases, basically. So if we clean this up, I'd have 3 quantity 4n plus 1 on the left side after cross multiplying. And then I'm going to call this 4n plus 5. Yes, 4n plus 5. So I would put that over here on the right side. And I think that what you could do is just simply get rid of your 3's, make your life easy here, right? And subtract 4n from both sides. And hey, I think 1 is less than or equal to 5, okay? Most normal people. Some of our dogs, we have smart dogs in our house that might know that 1 is less than 5. That could be a stretch, but so we're convinced there. So that means that although we have divergence up here, we've at least been able to salvage conditional convergence, okay? Even though the directions of this problem doesn't really state anything about absolute or conditional, it is up to us as students to know, because this is an alternating series, we have to make that distinction, but only for an alternating series. Okay, first person in the chat, part F, what would be your go-to test on F without any doubt? You see this thing and you're like, I'm not going to mess with anything else but the, what test? What test is it? Much respect to the person who can type it in the chat correctly. Nice job, Daniela got it. It is the ratio test. The ratio test is going to be the big go-to here, and I think you can just attribute that to the factorial, because we don't have any other test that handles that very well, right? We have no other test that handles that well. Now, I am going to go on a limb and think that you guys are pretty decent with your ratio test because we have already done it several times in this particular group of notes. I will tell you that this diverges, and if you want to play with this on your own to verify, you are more than happy to do that, okay? And then we'll just finish up here with G. What would be a great go-to test for G? There could be more than one answer, but there's one that I'm thinking in my mind. What would you guys like to do for G? Yes, Drew got it. Nice job. It is the root test. And you know what's so beautiful about this? This could be a quick hitting Roman numeral 1, 2, 3 kind of question, because if you take the root of this, the nth root, that goes away. And then if you have your limit, you get 1/2. 1/2 is less than 1. Boom, converge. I mean, that's how much work there would be to show. If that's even work that you're putting on paper, it's more likely in your head. And once you guys start to get really good at some of these where you can do many of them without like lifting pencil to paper or whatever, you're going to start feeling, really good about yourself. I've got an activity, a card sort activity that I hope to do if we ever go back to school. I guess Monday might be the day that we do that, more likely than not, since you guys have the quiz on 8/6 for Friday. However, I might leave some directions with Mrs. Ryan, because I think you could finish this quiz really fast on Friday. And then while you've got classmates around you, it would be nice to do this card sort, put you in some groups and you can just kind of play around. Basically, you just sort out all of these cards into columns of whether or not they would converge or diverge. So we'll see how that goes. So, hey guys, I'm going to stick around if any of you have any questions about anything that's in a homework. If you've started the review guide, that is like awesome, but I understand that you would have had to printed that out on your own. My plan is to give that to you the very next day that I see you. I have not heard any word about tomorrow, to straight up. I did hear some people talk a little bit passionately about a 2-hour delay, but don't quote me on that. I seriously doubt that it's going to be a complete full day out, e-learning day, because the temps are going to start to go up. But the morning, they thought that could still be a little chilly. So I will sit here in the chat, and basically until the last person leaves, that's when I'll turn off the Zoom session and then get my next one ready. I'm doing a college algebra one, but it does not start until noon. But thanks for coming. I really appreciate it, you guys. I know this is kind of dull and boring, and maybe some of you just kind of turned this on and walked away, and hey, that's okay. As long as you understand this stuff, that is the only thing that matters to me. I want you to do really well on this test Tuesday, and I think you can. I think this test has a pretty decent reputation. I've had years where it's been an outstanding test, and that will be good, because the next test, the last one, is a little tougher. It's not doom and gloom. It's not like the beginning of the year, nothing like that, but it can be a little tougher if we don't stay on top of it. So, all right. Definitely want to go over 8, 4, and 5, because I think that's important. So remember, we do have that Monday that I've got set aside to do things like that. My hope is by then I've got everybody who needs to make up those tests having made them up. So we definitely will. And in fact, my plan is to even go over 8/6 on those days. And that's why this was so important, you guys, because on a Monday, I couldn't go through all 6 tests and do a very good job. But now we've got, maybe half of them done. But M, that is definitely the plan. That is definitely the plan. Thanks for asking. All right. So again, if you need to go, that's fine. You can just close off the session. You just basically leave the meeting, I think is what the options are. You'll find it somewhere on your screen, and then I'll just, like I say, stay around if anybody has any questions. Definitely can. Number 15 on the 8-6 homework. I'm going to call up my 8-6 homework. Eight 8.6, 8.6, 8.6. Okay. I've got to make my 8.6 homework. It takes just 2 seconds here, Katie, so give me a second. You know, the other thing I could do is I could just look at my book and write it out too. I might do that. Let me grab that book. I'm really excited to get moving with this very next unit. You guys, it's so cool. It is by far my favorite thing to teach. Okay. So let me do this. Which one of these am I sharing? Am I sharing? I'm sharing 8-6 ratio and root test. Root test. Okay. So what I will do, if it's okay with you, and Katie, I'll need you to give me a yes in the chat. Is this the number 15 that you are dealing with on your homework 8-6 by any chance? Or not? Because we could be looking at different assignments. That's it? Okay, perfect, perfect. Okay, so this is just the spiral review, right? Test for convergence using any test that you've discussed, and identify the test and show your work. Okay, so, you know, this is going to follow the same pattern of thinking that we just applied, I think, on a previous problem. And Katie, I think you were the one that even talked to me about splitting this up. I hate to say this, but I'm pretty certain, and anybody can chime in and prove me wrong, but I think that this is going to be integration by parts. I think we have to use the integral test. Now, I know that the integral test is like our last ditch resort. So like, why am I bringing that up so soon, right? Well, the progression would be, okay, nth term test for divergence. You know, maybe we'll get really lucky on this problem. Maybe there's something that I didn't see. And maybe if we take this limit, which means we have to do L'Hopital's rule, right? Maybe by doing L'Hopital's rule, oh no, because this is 1/2n squared, that's 0, so no, that's not a good thing. This is not geometric, right? It's not a p-series. All those good ones are just dropping like flies. It's not telescoping. So root test, ratio test, I don't know, guys. If you ever try a ratio test on this, I'm going to be real sloppy here. Allow me to be kind of sloppy with this ratio test. I'm just going to write down the n+1 term, and then I'm going to divide that by the n term. I hope that you can kind of follow what I'm doing here. It's disgustingly sloppy, right? Because I still need absolute values and a limit in front. But do you all see how there just isn't the room, I guess, to simplify very well? You see with the natural logs don't play nicely with the ratio test, nor the root test. And by the time we've exhausted all of those potentials, we're down to either the comparison test or the integral test, which, you know, as a young child, that's like, you know, you got to either eat asparagus or Brussels sprouts. And I just look at this and know, we've seen problems like this in the past that use that integration by parts. And I just fear that that's kind of where we're going to have to go with this. The whole let V approach infinity, integrate from 1 to B, and you've got a natural log n piece and an n to the -2, and then you're off and going. You're going to let the u be ln of n, and then the dv would be n to the -2. Katie, do you want me to keep going? Because I'd be happy to. I mean, I'm not in a big hurry to get out of here if you want to see the next few steps, or if you feel like you're somewhat comfortable with where this is heading. So, okay, perfect. But I will say that 15 is the worst thing that you're going to see in that last group of 6 problems. Maybe that's why I left it for the very end. So, and Katie's question is also great in another perspective. If you guys look at a expression and you've spent a lot of time thinking about what tests you should try and you're just still stumped, it's a very good chance that it's probably one of the last 3. It's a comparison, direct or limit, or the integral test. Because I think you develop such an efficiency with those first 7 tests that you get them easily recognized. And that's great because that's probably 90% of the tests that you're going to come across anyway. So that's good. So Katie, Renee, Scout, Vicky, anything else that you want to ask me about? Just throw it in the chat. I know some of you just kind of lingered, just, if other people had questions that might have helped you, and that's great too. So. It's like pretty much everybody's in good shape then. Okay. Yeah. All right. Well, I got 2 more Zoom sessions today. Yay for me, right? It'll be very interesting. I've not done one ever with my college algebra group of freshmen and sophomores, so it'll be a touch and go if they even can get logged in. But they're smart kids. We should be okay. But I've done a couple with AB. So, all right, guys. Well, hopefully I helped you a little bit. If nothing else, we at least fulfilled our obligation to have e-learning. And if anybody says that you guys didn't partake, I will definitely defend you otherwise. So thanks a lot. The plan is that we will probably have school tomorrow, whether it's a delay or not. And then we can just get you guys, even more confident with what's ahead. Actually, I take that back. You guys don't have school tomorrow with me, right? If you're in period 2. But on Friday, Mrs. Ryan will be with you. She'll administer the 8.6 quiz. If you guys have any 8.6 homework issues, just throw them in that discussion board, and I can even log on and get you guys help as I'm preparing for my trip on Thursday night. And then don't forget, we will be back together on Monday where we can review a little bit more. Okay, so that will be the plan. So anyhow, thanks for hanging out with me, and we'll see you later in the week, guys. Have a good one.